Good afternoon, everyone. I hear the buzz of good communication and talking, and appreciate that. I'm going to call the meeting to order, however. I'm Jerry Meyer. I'm the president of the Resident Association at Givens Estates at present, this year at least. I have a very brief set of comments before we start the main presentation today. I appreciate that spring's here. I've usually been wearing my shorts lately, but I decided today I'd wear longer trousers. You weren't there to play bocce with us this morning, so you can heckle. So I wanted to comment briefly on our committees and their activities to date. We appreciate very much as the Resident Association Board that all 7 standing committees have submitted their goals for 2026 to us, and we did discuss them briefly today at a meeting that we had. And we appreciate that those committees have worked hard to set those goals, and we look forward to hearing about their great accomplishments later in the year. You know, how much do we make those things that we aspired to do during the year? And for all the committee chairmen and committee members present, you also submitted budget requests, and we approved all your budgets. So the money's there to be spent, and it's been allocated, and I'd appreciate if people would take it on and do it. And I'm going to point out, I'm going to embarrass Barry Miller back there. Barry brought some equipment that was purchased last year with Resident Association money to do landscaping work, particularly removing invasive species for the grounds committee. So that's one of the things that your budget last year was spent on. There were obviously many other very important things, but that's one example. So does anybody have any questions about committees or goals or comments that they'd like to make? Okay. So basically, today we're going to talk about the beautiful environment. Bruce Patterson is here to talk about games pollinators play, why spring flowers look that way. So Alan, are you going to come up and give a brief introduction of our great speaker?
I'll try to be brief. But before I begin, I wanted to point out that the 2 guys in the back would love to have you stop in and see them on your way out. They are helpers of our grounds committee. They have brought some tools of their trade, but in particular, they want to tell you about their activities in terms of eradicating the grounds from invasives and how you might help. So our speaker today, it's interesting. This is the first time I've ever introduced a speaker who just didn't need driving directions. When he visits us from his home, he just walks over on the perimeter trail, and indeed, he loves every second of it. He wouldn't come any other way. Dr. Patterson grew up in North Carolina, and his family was always avid in terms of hiking and love of outdoors. And the one thing they got from it, when they would walk the trails, they just loved the wildlife and the plants they saw. And if you take a hike with this man, it's a botany lesson. It's great. Growing up in North Carolina did not mean for him staying in North Carolina. He went to college in Ohio. He got his graduate PhD in California. He spent a lifetime working in universities in the field of biology as a teacher in Arizona and New Jersey. But once he retired, he was back to North Carolina. And I think his passion for the plants and the pollinators is going to rub off very quickly. It's my pleasure to introduce my son-in-law, Bruce Patterson.
Thank you. So you heard the actual qualification there at the very end. That's what got me here. Before I say anything else, I should point out that this is far too nice a day to be indoors listening to somebody talk. You should all be out walking on our lovely trail system. Couple things before I start. The little yellow instruction is important. If you're not sitting next to somebody and you'd like to chat with them a couple times during the talk about what you're seeing, get up and move. It's fine to do it while I'm talking. I can talk through anything. Okay, so as we go through the slides, there are a couple things I want you to know in advance about how the slides are going to look and what's going to be on them. So, by the way, that's how I really look, unlike the handout. If you see me on campus, it'll be that guy, not the nice-looking guy in the other pictures. So, basically, as we go through, you'll see all these pictures of flowers. And as they come up, first thing you'll see is a little date of when you can look for it, expect it to be blooming on campus. This year, maybe it'll be a month earlier than that, obviously, because we're having this bizarre weather. Eventually, after the slide comes up, there'll be a 5 or 6 second pause for you to discuss with your neighbor if either one of you knows what it is. And if you don't, just make up a name for it. You may well be right, and that's where these names come from anyway. I'm going to be using the common names. There'll be a handout at the end if you want to look up the scientific names, which is what you should do if you want to research them more on the web or do something like that. Last thing is, you see that big blue rectangle outlining the flower. If it appears, then it means that I've seen this flower somewhere on your trail system or nearabouts. And if you don't see one, doesn't mean it's not there. There are a lot of people here who walk the trails, who know far more about a lot of these aspects of flowers than I do. So ask your neighbor if they walk if you want to know more. Get involved with the walks if that's a thing for you. I'll have a little more advice at the end about how you can do that. So that's that. Okay, so I always like to try to explain why I deserve to be here, and not just by being a son-in-law. And as Alan said, though, all the professional stuff doesn't really count. I've enjoyed just wandering around looking at wildflowers for essentially my entire conscious life, and it never gets old. For me, going out in the woods is every time like going on a treasure hunt, because you don't know what you're going to see all the time, but whatever it is, it's going to be beautiful. And the point of my talk today is that there's going to be a story behind it. So that's me. My goal today is to convince you that every flower is worth looking at very, very closely, and most importantly, to think about. The question on every one of these slides is going to be, why does that flower look that way? And so I want you, every time you see a flower, to go, well, that's bizarre in its own way. What could be going on here? And I'll be walking through the whole thing, telling you stories about why things look the way they do. What did I do? I touched my iPad, but it has it shouldn't know about all this. Thank you. Okay. So, first thing is, we all grew up on the Bambi movies where everybody's in love and all good things happen except to Bambi's mom, which turns out rather badly, if you recall. But that is absolutely not the way it is. What I regret to inform you is that every day in the spring and summer on this campus, horrible, serious crimes are taking place in the woods behind you. Just to give you an example, bribery. That's the most common one, of course. We all know that plants are engaged in this sort of thing. And if you think about it, sex in the plant world, reproduction in the plant world is like nothing we think about, right? If I want to have kids, I have to woo my heart out, become as rich as I can, but it's sort of my decision, half of it at least, right? I have control of it. Plants do not. They never see their partner. They hope that a third party comes along and does their mating for them. Hence the bribes, but that's the nicest thing you're going to hear about. Oops, back up. I've got to back up, I think. Yeah. So, deception. Many plants look like they're offering a bribe, but do not. The gorgeous pink lady slipper, which you and I visit just to look at, offers nothing except a bit of an adventure in that giant pouch as the poor bee tries to get back out again. Jack in the pulpits offer nothing. Many of the ginger plants offer nothing. So kidnapping, which is a really good one. Many of the plants do kidnapping. If you know Dutchman's pipe, it's kidnapping its whole life. Jack in the pulpit again. Jack in the pulpit's going to be the star of the show because it's the most criminal plant that I know of in our area. Battery. If I start speeding up at some point, it's because I really, really want to get to the mountain laurel slide, which absolutely abuses bees that come in to pollinate it. Murder. If after the season's coming to an end, you pull up the top of the Jack in the Pulpit's pulpit, and we'll get pictures of all of these guys. If you pull it up and peek inside, you're going to see a lot of dead gnats in there because the Jack in the Pulpit does not care. If it's gotten the pollen from some other plant, its job is done. It does not care about the future of that insect. It was just using it for its own purposes. So impersonation, we're not going to talk about today. It's a thing that a lot of foreign orchids do. Some of them imitate female insects, and the male comes along and goes, "Hey, what's this?" And by the time it realizes it's nothing important, it's already coated itself with pollen or dropped off pollen because it's been making that mistake all day long. Okay, so we pause now for you to identify or name this one. Wild geranium blooms in March. So I just very, very briefly wanted to talk to you about what's in a flower. And we're not going to be technical. Ignore all these words because they don't matter today. What does matter is that in the innermost part, as shown by the pink arrow, oh, don't touch that button, touch this button. There we go. If you see the center of the flower there, that's the female parts, and it's all this stuff shown here. So the male parts come into, all flowers start off built on a ring system. The innermost part is the female parts. The outermost, the next part, is the anthers, as they're called. There we go. And the one technical term I'll use today is pollen, because I figure that one's pretty common. That's where the pollen's going to come from. The next layer is the bribes. That's pretty much what, or not the bribes, the visual attractant. That's what we're usually looking at flowers for ourselves, the petals, the sepals, and you already know where those are on the flower. And then some of this is bribes. Pollen is often not only the thing that the plant is trying to get transferred, some of it's given away as food for anybody who might be willing to do the job of transporting. A lot of plants also make nectar down at the base. We'll come back to that point a couple times because it may well be something you're familiar with. Okay. So, a couple flowers here. Do you know these? But note the blue box, they're here. So, my brother and I are the only people on the planet who call the white ones spotted fairy bells because spotted mandarin sounds a little pejorative and it doesn't really capture the flower as well. Yellow fairy bells is called yellow fairy bells. So make of it what you would. But the question is, why do they look like that? So what I want you and your conversant to do, and those of you at home, you must talk to yourselves. I'm going to turn on your camera on your computer and make sure you're doing what I ask you to do. So, what I want you to do is stop and think and talk about with your neighbor about what that actually involves. We all know that a flower wants to reproduce. Everybody does. The question is, how does it do that? So, what are the jobs that a flower is trying to accomplish? Talk. And if you want to move, you still can. If you want to talk to somebody and don't have a neighbor. Okay. Such that we can get to the mountain laurel, I'm going to interrupt what sound like a lot of good conversations, but of course you can continue all of these with anybody you want anytime. So the first thing you have to do, this is my list again, doesn't make it right or wrong, I'm just going to tell you what I thought of, is you have to get noticed. You have to be seen, and that's the only part of a flower that we often appreciate. But from there, you have to get the thing to come to you. Maybe you smell good. Maybe you just look good enough you can get away with that. But one way or the other, you got to get the pollinators to come to you. Somehow or other, you've got to get your pollen onto that pollinator, and you got to get it on in a pretty special place in most cases. It does no good to put it on the thing's elbow if that thing is not going to brush its elbow against the corresponding female parts of the next flower that it meets. So making this pollen transfer in an appropriate way is really the magic of it. And that explains a lot of the structure of a lot of different flowers because they have different pollinators doing different things. Got ahead of myself. Avoiding self-pollination is a big deal because incest is not as bad for flowers. They're more used to that kind of thing, and so they're a little more robust in that way. But if you can, it's always better to outcross, to mate with something different than yourself. However, a lot of plants, and we're not going to talk about this today, but a lot of plants have special movements that they do. If it's been a while and they go, well, better me than nobody, they have mechanisms whereby they then go, okay, I guess I will self-pollinate. So they'll play that game. And another thing that I had never thought of until I started doing more research and things is there's a lot of riffraff out there. There's a lot of guys that don't want things. You've probably noticed how a lot of plants are hairy or fuzzy. In general, that's because ants are not welcome here. They will come in, they will get the nectar, but they won't get the pollen on a part of themselves that will contact the appropriate parts of the next flower. Ants are great friends in terms of distributing a lot of spring wildflower seeds, but as pollinators, usually they're garbage. So you want to keep them, and anybody else who's going to take your nectar but not transact your business, you want to keep them out of it. So this is what success looks like if you take a blurry picture of it. So what I want to point out is a couple things. That's a wasp. That black object, darn it, I'm just not that smart. So that's the wasp right here. Oh, I forgot to say, this is spotted horsemint. If you thumb back through your Givens Gazettes far enough, you'll find that Robbie Whiting of Grounds, he, I think often monthly, writes up a section on some wild thing on campus, and there's one on spotted horsemint up there. The other thing that it doesn't show well here, but is there's nectar at the bottom of a tube on that plant, and that's what the wasp is working towards. But the really cool part is first look at the top part there that's circled, and you can see the male and female parts hanging out from the flower. What you can't see unless you walk up and put your nose against the picture, though, is that right here at the end of that arrowhead, there are those same parts neatly contacting the back of the wasp. So this whole flower is structured not just to get the wasp there, but then to get the wasp to position itself so that its back always touches the male or female parts. And the next flower will have the exact same structure, so any pollen deposited now will get scraped off on the next guy. The insect is not collecting pollen. It does not care. Some do, obviously. But this one just needs to be there as far as this flower is concerned for it to get its job done. Okay. First, take a minute and just look at all the diversity of structure here. And you can do your naming bit. So also notice the blue boxes. Every one of these blooms on campus somewhere. But the orange bits, that's not a rhetorical question. You and your talking partner or wall, if you're in a room by yourself, discuss why they would all look so different. If they're all trying to do the same thing, pull in an insect, dump pollen on it, get rid of it, why do they look so bizarre compared to one another? Go. So, again, carry on this conversation as long as you want with anyone you want. And it's fun, and especially even if you are not able to get out into the woods and look at things. I'm going to tell you about an application or a website at the end of the talk where you can go and look at pictures that people have submitted. So you can do your research and conjecturing from home if you like. All this is possible. So I'm just going to highlight one right now because we're never going to talk about it again, and it's one of my favorite flowers. Oops, let's see. Anyway, in the bottom right-hand corner, there's a picture of a passion flower. And you'll notice in this picture, you can sort of tell it's shaped like a dinner plate. Very flat, no interesting tubes or anything else. Well, its pollinator is the carpenter bee. And if you do a little reading, you'll find out that bumblebees have these monstrous long tongues that can go all sorts of places in a flower, but carpenter bees have very short tongues. So if you want to feed them nectar, you have to sort of put it on a dinner plate, like this flat flower here. And in the center, in a ring in there, there's nectar that the short-tongued carpenter bee can get to. And they both absolutely require each other. No carpenter bee, this flower won't get pollinated, and that'll be the end of things eventually. So every one of these has a story. And the fun part of my life is that some of these stories are known, you can find them, but the other really cool thing is, I assume most of us in this room are retired. All naturalists do is plunk themselves down in front of the thing they want to study and wait. We have time for that. And if you can't go into the woods again, find something you can grow on your porch. There's a lot of neat stuff in common grounds here that you can find. Last slide of the presentation has something called southern bush honeysuckle, which is blooming right around the lake where you go and eat commonly. So everything's here, and you can do a lot of the figuring out. My goal today is to put enough starts in your head so you're familiar with enough things that you can look at a flower and go, oh yeah, I have an idea about that, but then you can go outside and test your idea just by getting comfortable. And this is where I promised to mention Dan. He does forest bathing, as I understand it, which is mainly just finding a comfortable spot and soaking in what's going on around you in this lovely place. It's a great way, if you've parked yourself in front of a flower, to maybe be the first person to find out how a certain thing happens. Okay, so say goodbye to all these guys. So, columbine flower, oh shoot. Foot in mouth is my most common position, so. This is a columbine, by the way. Okay, so I want you to look at that flower and see what you see. You can either go, okay, what do I think it has? Or you can go, Why does it look that way? What might that part be doing? So just take a minute or two and discuss. Okay, in case it helps, I want you to look at those nice, tall, pointy things and ask how many of you in your youth or adulthood have engaged in robbing honeysuckle of its offerings. Yes! Honeysuckle, by the way, is one of the nastiest things in the world, and that's one of the things the gentleman back there may want to talk to you about in the end. It doesn't belong here, and things that don't belong here do very, very well, thank you. So, but the principle is the same. There's nectar in them thar hills. But even a honeybee doesn't have a tongue long enough to get up into that. So whose business is it? Hummingbirds. And if you look, and we'll look a little bit closer at this in a moment, if you look, there on the top of its head are the male and female parts of the flower that need to dust its forehead to do the transfer of pollen to the next one. It's designed not only to attract hummingbirds, but to position them so that it can do its business on the forehead of the hummingbird.
So is that the only thing that pollinates the columbine?
As far as I know, yes. I'm sorry, the question was, is that the only pollinator of the columbine? As far as I know, and that sentence means exactly as much and as little as it implies. Others may know more. The entire scientific universe may know more. But I know that it is pollinated by hummingbirds. What else is a good question? But whatever is going to do it has to have a long tongue. A lot of night-flying moths, by the way, have very long tongues. But you might ask, how would you design a flower to be seen at night when there's only moonlight? Think about it, and you're probably right. We're not going to talk about moths at all today. I apologize. Okay. So this is a quote from Carol Gracie, who wrote the greatest book ever for learning about this kind of thing. It'll be on a handout in the back if you want to get your own copy. You can also just ring me up and ask for mine. Their time of bloom, columbines, coincides with the arrival of the first ruby-throated hummingbirds to return to the eastern United States from their wintering localities in Mexico and South America. That's a really important idea. It's not just the structure and the appearance, the timing is critical. And one of the coolest things of all about the spring ephemerals, the flowers that come up just for a little while in the spring, is how precisely linked they are. Because again, if you're going to mate with somebody, if you're in bloom and they're not, the game is over and you have lost. It does not pay to be first. It only works if you're with the crowd. And that's one of the scariest things about the warming weather. Because if the bees are listening to different signals than the flowers are, they'll not be in sync. Bumblebees are out right now. Those queens need to eat or they will die. They die, there's no colony. There's no colony, there's no bees. There's no bees, the plants cannot get pollinated. Game over. So we can lose it all if we let things get too far out of control. So just as a peek, this is an extreme close-up. You probably figured that out already. There's the male and female parts, and you'll notice that the female parts, the little skinny bits that stick out furthest, are not exactly where the male parts are. They'll both contact the hummingbird's forehead, but they won't contact each other. So this is a way of at least decreasing the amount that the columbine pollinates itself and emphasizes somebody else coming along and helping out. Okay, so first, identify these. All but the last one I've seen on campus. Doesn't mean it's not here. So you may notice that besides the flower, there's a common element in these pictures. Hummingbirds. Some of you are well ahead of me, and thank you. You and your partner, if you were a hummingbird, what might you be looking for that all of these flowers have in common? Go. Okay? So the audience says, red color. Why would the hummingbird bother coming here? It's visible, but it's not an art appreciator. Why did it come? Nectar. Every one of those you could do the honeysuckle trick on. Bite off the end of it, suck, and you should get nectar. Do not do this on my advice, because you also might get something that kills you and not birds, because the plant does not think you're going to pollinate it and you're a waste of its time. So always be cautious when anybody tells you to eat anything, especially me. Okay, but yes, the common elements are every one of them is red and everyone has a tube. And as well as that, if you look, and you can't always see it in all these slides, so you're going to have to take my word for it, which is never a good thing to do. So go look at one yourself. But the male and female parts are in the same relation to the hummingbird's forehead on each one of these flowers as it was in the columbine. So they're not just pretty, they're not just full of nectar, but they are built so that to get that nectar, if you're a hummingbird, you got to stick your forehead in the plant's business. It's the only way to get the job done. And that one didn't have a hummingbird in the first picture. So if you see orange around a picture, I didn't take that picture. And the attribution should be somewhere on the slides. This was taken by Jean Gregory Evans, whoever that may be. So, now this is interesting. These are two different flowers. They're near cousins. Okay, I put the scientific names up here just to emphasize that. You'll notice they're both kinds of lobelia. Okay, that's a technical thing. All you need to know is that they're near cousins. They don't look very much alike. They're not the same color. They're largely not the same structure. So let's take a look at what is true of them. As we've already seen, this one is red, which we have come to understand seems to be a hummingbird thing. We'll talk about that in a minute. There's nowhere to land. Those petals are floppy. So unless you can hover, you're not going to get a chance at this, unless you're your size or my size, but we don't generally do the pollinating of this kind of thing. And there's a nectar reward at the bottom. But if we look at this cousin, who has severely changed its appearance, despite being very closely related in history of evolution and such, it's called Lobelia syphilitica because people used to think that it cured syphilis. Thank goodness we have a little better science these days. Oh, sorry. There it is. And again, you can see in the picture at the top of the hummingbird's foreheads, that's the male or female part of this flower. These blue ones are blue for bee eyes. And we'll talk about the difference in eyes in a moment because I think it's important enough to bother with. There is a lovely, firm platform for landing on. So if you can't hover that well, or you need to get your excessively long tongue to the end of the flower and it takes some time to do that, you can do it if you're a bee. There is a nectar reward, but it's also, that's pretty much a jail trying to get through that. Something you need to know is that bumblebees and carpenter bees are flying tanks. If you want to exclude somebody, just put some stuff in the way. You won't stop the bumblebee, but you'll stop smaller creatures that may not have the parts in the right place to get to your nectar and things. And so there it is. That's a bee helping itself to the great blue lobelia. And I've just put the arrow where the male-female parts would be. And I forgot to show you, so I'll just make an assertion. Oh, it's still here on this side. If you look here, okay, there you go. If you look at this thing, that's really cool. That's the male state of it. If you go back and look at the PowerPoint later, you'll see that on the cardinal flower, that male part is split open and a little further extension has come through. That's the female parts. So any given flower of these lobelias is either male or female, not at the same time. Male parts first, then those break down and go bad, and the female part comes out. So early in its life, these flowers are male. Later in life, the flowers are female. Okay, so this is the technical bit, and it'll be easy, and I think it's really important just to take a look at this. So on this slide is how you see the world on the bottom right-hand corner. So basically, you have 3 machines in your eye. Each one can see a different range of colors. And from left to right, as is shown by the coloring of the little display, one of them is pretty good at detecting blue, and then the other 2 are pretty darn similar to each other. And the story behind that is fascinating and takes an entire hour, so I'm going to skip it. But you can see that's how we tell red from green, if we tell red from green. We compare how loud the signal is from those 2 humps. And if it's louder on the one on the right, it says, yo, make a movie of red in the watcher's mind. If it's louder on the one more towards the middle, it says, yo, show green. If you only have one of those hills, there's nothing to compare it to. And your brain says red and green are the same thing. And that's where red-green color blindness comes from. But the point of showing that is to show you what hummingbirds look like. They've got much better distribution of the colors they can see. They have 4 machines reading color all the time. And if you look towards the right, you can see that their ability to tell red extends well beyond our ability. So they're really good at red. So if you were choosing to try to get a hummingbird to see you, that would be a good idea of color choice. Now look at bees. They've got nothing over on the red end. They don't see red as a color. It's invisible to them. But as we say in Wizard of Oz, but there's one thing they could do. If you look on the left, I'm an idiot. Okay, if you look on the left side, you see that hump in black? That's something we cannot see. That's something beyond violet for us. And so, since we're the center of the universe, we have named that ultraviolet, the violet beyond the violet. Okay? Bees can see that. So that says, well, bees are equipped to see things that humans cannot see. Flowers know this. So if you look, what is this? Bloodroot. And as you see on the slide, currently blooming on campus on the trail system. There's much of it, or a lot of it, can be seen in the near the health center. Those are trails that run right around the health center. I'm sure it's everywhere. That's what you and I see. That's what a bee sees. Now, it's a little more complicated than that, of course, but the part of the bee eye that can see that kind of color sees the petals as bright, as showing the thing that it can see, but the center is dark. It's eating the light. This bullseye theme is very, very common in bee-pollinated flowers, and we just never see it unless you go out and buy an expensive camera that does this kind of thing. Who are these guys? All of them bloom in March. take a quick look. I'm going to put up another slide now just to the flowers. So look at those flowers as you and I see them. And they're lovely, but the centers on several of them are kind of subtle. But to a bee, they've all got some sort of a bullseye marking that's completely lost on us, that's driving the bee to come see this, and that orients it. The good stuff, it's somewhere near the bullseye. Concentrate your attention at this location. And the dogwood is sort of interesting. It's the only one I've heard of that's bright in the center and dark on the outside. That probably means something to some insect, nothing to me. And no, I didn't discover that. I just took the picture after someone told me that it happened. Okay. So, trout lily is even cool on the back side of the flower. It's pretty, and it also shows that same patterning to a bee's UV vision. Okay, so let's talk about that other aspect I mentioned, keeping the guys you don't want stealing your nectar from getting your business. So this is dwarf crested iris. It'll be blooming soon around here. But one of the things that's really pretty and interesting about it is, is that rough stuff coming out of its tongue. And I will assert to you that the nectar is at the end of that tough road, all the way down a tube towards the center of that whole purple flower. Okay, so you got to get there. Now, if you're a bee, you're huge and you're strong. And in case you can't make it out, that's a bee butt right there. Okay? So the bee has muscled its way in past that really interesting corrugated center to get to the nectar. But some wimpy little bee that's not going to have parts in the right place is going to get stuck knocking on the door and is not going to get anywhere. Now, you might be saying, and should say, Bruce, maybe that's just the way that flower has to be made. Heaven knows you can't make that tongue without the corrugations on it. This is a cousin. It's called vernal iris. Largely the same, but of smooth entrance. So I conjecture here and now before you, without knowing the answer, that somebody else pollinates this guy, and that's why this flower is different. It's serving a different audience. I have not found out an answer to that by research, but if you see me plunked down in front of one of these using my retirement time, it'll be waiting to see who comes and visits this guy. Okay, so this is really neat. This is just sort of, bees are cool. But this is the ultimate example of forest bathing. So this is a movie. Watch the left lower flower there closely. So there's the bumblebee. And watch this. Watch the little back leg struggle. It tries to get in there. Right? If you look at, I was told by somebody that turtlehead, this is pink turtlehead, flowers don't have pollinators. Because if you look at it, the door's closed. Right? Take a good look next time. It blooms on campus. You can find it somewhere. Take a good look. It's hard to get in there. Sort of like a snapdragon. Same kind of concept. But the reason is because it wants a bumblebee. And a bumblebee has the muscle to get in there and do the business. So, speaking of bumblebees, there's this really, really neat thing that bumblebees do. And they'll do it, among other things, to spotted wintergreen, or Pipsissewa, which I can never pronounce, but I like the name better. So, notice how this bee is positioned. This bee is going after pollen, okay? Doesn't matter where its tongue goes, that's not what this flower is about. But what he's going to do is he's going to shake his little bee butt. Because as you can see here, this is just a close-up of that same ring that the bee is focused on. And those things look sort of like salt shakers, at least to me they do. They're full of pollen, but the pollen's only going to come out if you vibrate in a certain way. So here's a little movie. And watch, you can see the flower petals dancing here. That's because the bee is doing this vibration. So if you look on the right side of the bee or very close to the white part of the bee on the left, do you see the sprinkles coming out? That's the bee doing what's called buzz pollinating. Instead of flapping its little wings with its muscles, it's just vibrating, and it vibrates at the right intensity. You can actually hear the bee change its buzzing noise when it goes into this, because apparently they know exactly what's needed to get this done. Okay? There's a lot of flowers that do this. All these engage in this activity. Take a minute, see who you recognize. Notice the blue boxes. Everything here is available for you to sit in front of it and see if I'm lying to you about buzz pollination or not. Those 6 on the left are all nearer or farther cousins to each other. So this trait sort of runs in the family, if you will. The one on the right is of a different group, but it's related to tomatoes. Tomatoes are actually buzz pollinated, and if you carry an electric toothbrush with you, stick it up against some tomato flowers. I've done this, it actually works. And you will be able to get the pollen to come pouring out if you just hold your electric toothbrush to the flower. There's probably a more sophisticated way to do that, but I don't know what it is. Okay, Jack in the Pulpit. Jack in the Pulpit's kind of neat. So look at it. First thing you need to know is that Jack is not the male parts or the female parts. They're down here in the center of the tube. The other thing you need to know is that it's Jack in the Pulpit or Jill in the Pulpit. Okay, that's not my invention. That's the way you'll read it written up everywhere. What's going on here is this. If you're dropping pollen, you're not done yet, right? You've got need that pollen to go somewhere else. It's very, very hard for gnats, who are the pollinators of these guys, to fly in there. That's one of the things that Jack is doing. Jack's just clogging up the center, so you can't just flap your wings and get on out. You've got to crawl out, and that entire tube is waxy and slick. There's no crawling out of this, okay? So, male Jack in the Pulpits have an escape hatch. So after the gnat is hopefully covered with pollen, we're going to say, okay, fine, you can go find a female version of Jack in the Pulpit. But the female version of Jack in the Pulpit does not have an escape hatch. Because if a gnat has come in covered with pollen, the interests of the flower are you stay as long as possible to make sure that I can extract that pollen off of you at some point. If you wander around till you die, that's fine. I got my pollen. That's what I came for, okay? And just to show you that we're not talking bunkum here, on the left you see the innards of a male Jack in the Pulpit. Those are pollen-releasing structures up there, and they're sort of higher up because the pollen can rain down on the gnats while they're searching for a way to escape through the hole, whereas the female has lower structures where the thing's going to be crawling around in its death throes before it's all over. Another neat thing about Jack or Jill in the Pulpit is that you're probably all familiar with the fact that reproduction is a lot more work for females than it is for males. Same is true of Jack in the Pulpit. If a Jack in the Pulpit has stored up a lot of energy, it'll be a girl because it will have the energy to grow seeds after pollination and do all these things. If you don't have a lot of energy, you say, well, I'll just be a male, make some pollen, call it a day, and you get bigger. So they will not be the same sex time after time. They'll always be one sex or the other, but one year they might be male, another year they might be female. And that's, by the way, another way of avoiding self-pollination. If you're a male this year, You're not going to get pregnant from yourself because you have no female parts. The only way you're going to reproduce is with somebody else. Okay. There it is. This is a stolen picture, but there is the tomb of many gnats who hopefully brought pollen into a female. And I have a picture like this too, except it's only got one gnat in it. But again, this is the kind of thing, if you're careful, you can pull up the little hood of the Jack in the Pulpit and look in there for yourself and see if it's actually catching and killing things. You can look in the front and see if you can find an escape hatch, which suggests it's a male, or if it's all sealed up, which suggests it's a female. And one other cool design feature that we don't necessarily notice is there's a light at the end of the tunnel. Part of the design of that pulpit structure is that it's brighter at the bottom. And that's another signal that there's good things down here. There are not actually good things down here. There's no food, but the gnats do not know this. There's stinky smell, perhaps, which gnats apparently like, and they'll go down there to that sort of thing. So that's Jack in the Pulpit. Kidnapper, murderer, deceptor. Okay? All those things are in its bag of tricks to get pollinators to come to the place they need to come and do the things that they need to do. Okay, cool. This one's really cool. Who is it? Mountain laurel blooms on campus. Take a look at that structure. One, the buds are pretty much the most gorgeous thing on the planet. They're the things that look like cake decorations in there. But the buds have that fascinating structure because they have to make a flower that has a fascinating structure. So you and your partner, see if you can identify where the different male and female parts of this flower are, and take a minute to go, why are they there? Go. So if you remember our talk at the very beginning, what's at the very center of the ring system? Female parts, the lady bits, yes. So the next ring out, those curvy things, that's the male parts. And the pollen heads, this is insane, the pollen heads are all buried in their own little crevice around the ring, right? That's why you have that fancy cake decoration when you're looking at the bud. That's the formation of the rings that are going to trap the pollen heads. Now, why, oh why would a plant trap its male parts and keep them away from visiting insects? Because that's not the end of the story. Those are springs. And what they're going to do is, when a bee comes up and disturbs that thing enough, it pops free and smacks the bee with the pollen that's coming out of the little thing. So watch the movie carefully, and you in the booth, I may ask you to help me show it again because I don't know how to do that. So that at the there it comes, boom, right? And I don't think it's going to cycle. Can we show that one more time? Perhaps not. Okay. I'll put it on a website somewhere and put up a link and you can see it. But with those things, well, better answer. There are mountain laurels that bloom on campus. Take a toothpick. I've tried it and so far haven't had any luck, so I'm apparently a very bad bee. But in theory, if you push them the right way, you should be able to trigger right in front of the eyes of your own face. You should be able to get that thing to launch and release the pollen. But that's the game that these guys are playing, okay? That whole structure is built to have a spring-loaded trap that when a bee comes in and brushes something the wrong way, slaps the bee, transferring the pollen to it, And hopefully the next time you see the central structure in this one, that's the female part. So hopefully wherever the pollen got deposited, it will contact that female part. Yes, there is nectar in the bottom. I think there's something called mad honey, because whatever's in that nectar causes hallucinations and not so good things. So this is definitely not one to pull off the plant and suck on out of curiosity to know that if it has nectar. Okay, I'm going to call it a day there, and we'll skip that, and we'll skip that. Cool stuff, though. Very quick one, just very quickly. There are 38 kinds of trillium in this country, and in the Great Smokies, there are at least 13 of them. Some of them smell different. Some of them have different colors. I don't know the stories of 9/10 of them, though 2 of them at least are found on campus. There's a reason why each one of those looks the way it looks and different from the others. Great thing to conjecture on, to read on, to look up, or to plop down and watch and see who interacts with this and figure out how they're doing it. Another cool thing. Okay, one more. There's a handout on, I think, the back left table. Don't forget the gentleman in the back right table want to talk to you about what you can do to help preserve these wonderful things we have. But a couple things. My favorite book, Carol Gracie, Spring Wildflowers, does an in-depth talk about a small number of flowers, but it tells this kind of story. Some of these I pirated from this book because that's where I first learned about them. For armchair observation, iNaturalist, it has an app, but if you access the app, one of the things it does is it shows you the Wikipedia page with everything known about that flower. It also has user pictures, hundreds of them in some cases. They're not taken for our purposes, so you have to go through them, but you can certainly look at the structures of the flowers. Maybe there'll be a pollinator in them, but you can conjecture as to what's going on with that particular flower. Walkable, labeled, and local. You can go to several places where they've got walking trails around here. In many cases, the flowers are labeled for your enjoyment. Highly recommended if it's something that you're up to. My personal favorite identification book, Wildflowers of Tennessee, the Ohio Valley, blah, 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 in case you want to go that route. Again, talk to your neighbors. They may have a different favorite book, and it may work better for you than mine works for me. Lastly, I cannot emphasize enough the value of your backyard or planter or community in terms of getting something that you can grow yourself and watch without leaving the comfort of your home. One caution, rich forest soil is not North Carolina red clay. So beware of something that grows great in these exotic, rich locations. It may not grow in your backyard. However, anything that has the last name of weed, pokeweed, ironweed, jewelweed, these are all very robust things that you've got a good chance, but do pay attention to size. The Prairie Moon Nursery website, and I love the plants and seeds I've gotten from them, actually lets you say how much shade does this plant like, what kind of water does it like. It'll often tell you in the text if it likes rich forest soil. Okay? So go forth and look at things and think about them. Thank you very much for your time, and thanks for everybody who helped me put this together.
Folks, you're invited to ask questions, but before you do, if you have questions, I'll pass the mic to you, but I just want to turn the lights on so you don't trip on your way out. Just give me a minute.
So I want to say thank you to Bruce for his great presentation. And he didn't tell you this, but he has a badge on that says he's a future resident.
Sorry.
And he lives right next door in Park Avenue. So as Alan said, he uses our trails regularly.
Not only does he use our trails, but he is, I guess, officially a grounds helper's helper.
There was a question back there, Alan. I think somebody had their hand up. I thought maybe not. Yeah, right there. Yeah.
So if we feed the hummingbirds the nectar, does that keep them from pollinating? Should we
Not that I
not
know
feed
of.
them nectar?
But it's always more fun to see them doing their real thing. So get some jewelweed, also known as touch-me-not. You'll often hear complaints that you can't stop it, which also means that you can start it if you want some. I've seen them there. Cardinal flower, which is tougher to grow, requires moisture, likes a little richer soil. I've seen hummingbirds come to that naturally. So I personally am not an expert here. I don't know, though, that you're causing a problem, but it's so much more fun to give them what they're looking for and find native things. And you now know 4 of them: cardinal flower, jewelweed, scarlet bee balm, and whatever the 4th one I had on that slide. Columbine. Thank you very much. Yes, columbine. The one, and again, columbines are out here. You can find them, and you can enjoy whatever's going on there with a little bit of patience. Maybe.
Other question?
Yes.
Well,
Wait for the
Get-
mic wherever you
yeah.
are.
Thank you very much. I wanted to put in a plug for a talk that we're going to give. I'm speaking for the Grounds Committee here. We're going to be giving a talk on Earth Day, which is April the 22nd, in which we will be really extending or making more personal plants that we can grow here. We're going to show you a nice video from Doug Tallamy, who is a really well-known conservationist, about why we need native plants. And it talks about the whole web of life, how we need the right plants in order to have the right food for the birds. And the food for the birds is the insects. All of these things evolve together. So we're going to talk about that, and then we're going to encourage everybody to plant outside their apartments, in their patios, wherever. And we'll give you some handouts with some nice native plants on them. So if you are interested in the planet and in what you can do personally, is plant native plants. You can have personal effect. Anyway, it's April 22nd at 2 o'clock in Rising. Thank you.
anybody else
Thank
have a
you.
question, comment? Or-
Am I missing anybody? Anyone else have a question?
Yeah.
Okay.
Go forth and enjoy a lovely day. Thank
you,
you all very
everyone.
much.
I want to brief mention
Don't go
before
forth.
you leave. Next month is our Earth Week, Earth Month celebration. The program that Barbara just mentioned is part of that. And we also have our speaker for next month, Christine Mock, is here observing. She will be talking next month about microplastics and how they affect the Earth and our world. So we look forward to seeing you next month, April, whatever the date is. Thank you for your attention.